All right. All right. We're back at it again with some amazing blockchain programming. And today we are going to implement our TCP transport. Why? Because in previous streams, we wanted to sync the blocks. And enable to sync blocks, we need to send a lot of messages, and the current implementation of the TCP, not the TCP, we don't have any TCP, the current implementation of the transport layer, the local transport layer, it was a good implementation until yesterday. We had some issues, and I didn't like it anymore. So I decided, why don't we implement our own TCP implementation for the blockchain? It's a very underrated aspect of blockchains, because the gossip protocol, the TCP layer, the networking is very important, because a blockchain is sending messages across the network at a very rapid pace. So it's a very important and crucial aspect. Let me first notify the world that we are doing amazing things right here, right now. So, and I hope the camera is working today, because yesterday in yesterday's streams he was overheated. He or she, I don't know. The camera was overheated, and but I changed some settings, so it should be good right now. So let me first check if Nightbot is at the party. I'm not quite sure. How can I see this? Participants. I don't understand. Where is Nightbot? Why is nobody joining the chat? Let me see. VS Code. VS Code. Nightbot. No Nightbot. Unfortunate. Aha. Nightbot is there. Welcome, Nightbot. Cool. So I have some two commands. The VS Code command, ! VS Code, to find out what my settings are. It's on a GitHub repository. And ! color scheme, if you want to know what color scheme I'm using, which is Groovebox, the hard version. All right, so let's get started. So what we're gonna do is our TCP transport. It's basically completely from scratch, right? So we are going to create a new file. We're gonna call this TCP transport go, like this. This is our server. All right, we're gonna say package network, like this. We're gonna create a new structure, which is type TCP transport. Gonna be a structure. What do we need? What do we need? We need a listen address. Listen adder, it's gonna be a string. We're gonna embed our listener into the struct. Listener, we're gonna call this ln. And it's going to be a net listener, I think. Yes. Then we're gonna make a new function. Some kind of a constructor. And I hope this mic is at a good position. New TCP transport. That's gonna return a pointer to our TCP transport, like this, and we're gonna return TCP transport, and we're gonna give it an address, so we can instantiate this with an address, like this, and it's going to be a string. So we can say the listen address is going to be, and actually this can be private, to be honest. It's going to be the address, and our listener, that's for later on. Main. All right. So the first thing we're gonna do is we're gonna make, T is gonna be TCP transport. We're gonna call this start to boot it up. And we're also going to have a private function, which is going to be TCP transport accept loop, like this. All right, so for start, what we're gonna do is we're gonna create our listener. So we're gonna say ln for listener. Error is going to be net listen. We're going to listen to TCP, and we are going to say that the address we are listening to, is going to be the t listen address. And if there is an error, maybe we should return an error. We can return the error like this. And if everything goes well, we're going to say that the listener, actually, yeah, ln. I'm questioning, is this readable, ln? Is this readable? Listener, why not? Listener is going to be that ln thingy, all right? And then we're gonna return nil. And we're also gonna say something like fmt sprintf. We're gonna say TCP listening to port, and then something like this, listen address, right? And actually this can be println, why not? All right, so what we're gonna do in this main function, we're gonna basically comment everything out because I wanna test stuff. So we're gonna say nothing. We're gonna comment this all out, and then we're gonna make a new main function like this. Let me quickly see if the stream is all okay, because YouTube, you never know. Sounds good. Wait, let me, boom. All right. So func main, what we're gonna say is the server is going to be actually TR for transport is going to be a network, new, not local, new transport, TCP transport, by the way, like this. And we're gonna give it an address. Let's say we're listening to 3000, and then we're gonna say tr start. And later on, we're gonna embed this into our own blockchain, into the server of the blockchain. But quickly for testing. So tr start, what are we doing? We do net listen, yes. All right. Let's make run to see. Okay, listening to port, good. Okay, next thing. If we start this thing, we're gonna boot up a Go routine, and we're gonna say transport accept loop. That's important because we're gonna spin up a new Go routine that's basically listening for incoming connections. And for each incoming connection, we're gonna make a peer and I'll do all that good shenanigans, that good stuff. Go accept loop. This is going to be a for loop. And we're gonna say a connection, an error is going to be t listener accept. If there is an error, we cannot break the loop, because if we break the loop for a bad connection, we're basically breaking the loop for everyone, and that's not a good idea. So we're going to say something like, maybe we just print it out, printf accept error from, and that's going to be connection. And actually what we could do is verbose and a new line, and then we're going to say continue, right? Ish. All right. And if all goes well, we're going to print out, printf, again, verbose and a new line, the connection. Okay, just to test things out. Just to test things out. The next thing we're gonna do is nothing. We're gonna make something like, just to test, right? This is quickly testing it up, and now we're gonna make it better, embed it into the blockchain and sending messages. But first things first. So we're gonna make something TCP connector, TCP whatever, TCP tester. This is what it is. So we're going to say connection R is going to be net dial. And we're going to dial this address, right? Do we need to say that we're going to dial TCP? Probably we do. If R is not nil, we can just panic because this is a test function. We can just panic, no worries. R and this connection we don't care actually. The only thing we care about is that if we do this, let's boot up a Go routine times sleep 1 times second. And the reason why, because we're booting up our server, and if we instantly send a request, it will not work because it's still doing this Go routine stuff. So we're going to sleep 1 second and then we're going to say TCP tester. Okay? Make run. Wait, we need to select here. And this is a nice trick. If you do a simple select statement right here, it will block. Why is that needed? You probably never need it, but for testing purposes, that could be interesting if you want to block. You can just do select with these, how do you call this? Curly brackets, right? Yes. Make run. Boom. All right, you see this connection here, basically it works. So that's basically this logging, right? Where is here? So what we could say actually is something like new incoming TCP connection, or peer actually. TCP peer, new incoming connection, why not? New incoming connection, this, reboot this thing, make run. New incoming connection from, and that's the connection. That's basically our TCP tester that is connecting to the server, to the TCP transport, okay? All right, so, hey buddy, Avinash, how is it going? What's poppin'? How is your day? How is your morning? My morning is good, and the reason for that is because you are here. And today we are basically, yesterday we had some issues with the TCP, not the TCP transport, with the transport layer of our blockchain, which was the local transport. And I really didn't like the implementation. It worked until it lasted, which was yesterday. And I decided, why don't we do TCP? Why don't we implement our own TCP network for the blockchain right away? Because first of all, TCP networking in blockchains is very important. Gossip layer and all that stuff. Also important for consensus. And TCP, knowing how to do TCP in Golang is also very important, because as a Go engineer, you probably will do a lot of distributed cloud networking things. Distributed databases, distributed whatever. And knowing TCP, knowing how it works, knowing how to do this in Golang is super valuable. If you're a blockchain developer or just some other Golang developer, even a backend developer in general, TCP is the best friend. Going good, mate. Here it is evening. Oh, good evening. A good evening, my man. Okay, so we have this accept loop. That's good. So what we're going to do is we're going to transform each connection into a peer. So where are we going to do our peer stuff? We're going to say type. Actually, I'm going to do it on top because that reads a little bit better for you guys. So we're going to say type TCP peer is a struct. All right. Whoa, what's going on? VS Code. Hello, help. Like this. And a peer is basically just a wrapper around the connection, around the TCP connection. So we're going to say the connection is going to be netcon, a pointer. Do we need something more? We will do some other stuff, I think. Let's first make this peer, because we're going to save these peers. We're going to save these peers into a map so we can keep track of it. So we can broadcast to all the peers, right? All right, so what are we gonna do? So yes, we are going, and I'm thinking, should I do this read loop into a peer or should I don't do it into a peer? That's the question. We can refactor it actually. So what we can do is something like a new function, TCP transport, a read loop. Or maybe we should do handle con. Read loop is better. Or not. Design decisions. Read loop. And what do we want? We want a connection. Netcon. Or maybe we want a peer. That's a good question. So basically we are in this connection here. We could say something like peer is going to be a TCP peer. Actually, do I want pointers? Yes, I want. TCP peer. The connection is going to be this connection. Right, and then we could say something like go. Read loop. And we pass in the peer. So instead of this connection, we could say peer, TCP peer. What is going on? What is this? Cannot use variable type netcon. Oh yeah, netcon is this an interface actually? That's a good question. It's an interface. Never do this. Interfaces don't use pointers, although it can be pointers. Underlying. Accept error, yeah. Make a peer and do the read loop. Each peer needs to have its own read loop. Each incoming connection, we spin a new go routine so we can read from that connection, right? So basically if 10,000 people are connecting, we have 10,000 go routines all reading from their connection. So we can process messages. And of course, very important is, and you will see later on that for each message, we need to make sure we don't have any race conditions if we're processing them. The question rather is, maybe we should print this here, right? Or not? Like this. And let me see, is Nightbot still here? Help. Whatever, Nightbot just joins whenever he needs to join, apparently. Let me test the command, to be honest. Color scheme. Nightbot is sleeping. So read loop. A read loop is a loop, like usual. So we're going to say for. Man, this Nightbot, what a delay. So we're gonna read. And now I need to think a little bit because peer con. Read. Wait, so what I'm gonna do is, I think it's n. Read, what does read do? No definition for read, that's nasty. I think it's bytes, b is going to be this, right? Let me make a bytes. Can I do this? I'm not quite sure. I'm testing things. Onias, hello. What is up? What is up, my man? Welcome. Wait, let me quickly see. So we're gonna read from this connection. Maybe I should do something like a buffer and read from it like this. There are a couple things we can do. We could say something like buff is a new bytes buffer like this, and then we could do maybe buff read from the connection. Like this, maybe. Cannot use speed.com. Oh, it reads bytes. Okay, so that's not gonna work. I'm pretty sure we do this. Error. Peer connection read. It reads bytes. That's true. So we're gonna make a buffer, but we're gonna say it's gonna be a slice of bytes. Let's say this 2048, right? And then we can read the buff. We can read the buff, right? And then if there is an error, if it's not nil, we are gonna print out the error. We are not going to quit the read loop, because sometimes it could be that our user or other node sends a wrong formatted message, and if we then cannot decode it for some reason, and we say return the error, and our read loop is basically broken, then the connection is completely gone. So we're gonna just print it out and then continue waiting for the next message. So we're gonna say read error like this, and we are going to, I think it's an error, so we could do like this. Okay. So we allocate this 2048 bytes, and we're gonna keep that. We're gonna keep overwriting this buffer, so we don't, it's very memory efficient, right? And we can actually adjust this number. We can lower or higher it as we want. So very important is, by the way, so we read this bytes, and then we're gonna say, for example, just to test, the message is going to be the buffer we have, and we pass in the length. Because what read does is basically it returns you the amount of bytes it has been it has read from the connection. Wait, and this should also return. Exactly, it returns you the amount of bytes that has been read and the error. So to exactly know how long the message is, we can paste in this number into our buffer, and we can have the exact same bytes that has been sent. So we could do something like print ln, and if we want a string, we can say string of this MSG, all right? And of course, here we're gonna handle the message. Handle the message, but that's basically our server that's gonna handle this, right? Okay. How can we test this? First of all, I'm gonna try it real quick. We don't send any messages, we just connect them. Okay, so we have a new incoming connection. Why? Because we have this TCP tester, and I will implement everything into our blockchain, right? So I will inject the TCP transport into our blockchain, but for now I'm testing this real quick. That's why I'm commented everything out in main, so we can test this. So what we're gonna say, look at this. So I'm gonna say connection. We're gonna write. I'm gonna write a byte. I'm gonna say hello world. Actually, hello you, because I'm sick and tired of this hello world. Not gonna lie. Yeah, that's what I'm gonna do. Let me see. Write an int and an error. We don't need the int. We want the error. I'm going to say if r is nil. And in this case, we can just panic because it's a test function, right? So we're going to panic. Man, I still need to warm up. Not going to lie. Error. Like this. And that's not working. What's going on? No new variables. Yeah. Okay, cool. It's fine. It's fine. So we're going to connect and we're going to write to the connection. Make a run. Let's see what's going on. Boom. Hello, you. You see? So we received the message that this TCP tester is sending. We connect. We send hello, you. We read that from our shenanigans and we print that out. So that's kind of working. That's the basic of TCP. That's the basics. What's going on with this? The very basics. And now we're going to do the more fancy stuff, right? The more fancy stuff. All right. Can we make this more spicy? That's a good question. Can we do like for like this? Let's say 10, and we do this. Not quite sure this is gonna work. All right, it works. So we're spinning up 10 Go routines that each connect to our server and they send hello you to us. That's what we do. And it works. So no issues, no blocking, no panics. It's all working fine, just for the sake. All right. We can do two things. Or we already implement this into the chain and go from there, or we just try to... We're going to implement it already in the chain because I think the map of peers needs to be on chain, on our server struct from the blockchain and not here. So what we're going to do is we're going to server, or blockchain server, and we are going to eliminate a lot of things. Because what I want to do is... Let's first do this. So I'm going to delete the transport. I'm going to delete this transport. So that basically means that this shenanigans can be... I'm going to comment this out. Bootstrap nodes, we're not going to use this. Init transports, we are not going to use this. Bootstrap nodes, that's going to be a completely different function later on. So we're going to cut that out. This is basically send status message that can stay, but we're going to comment that out because it needs a little bit of more attention, just like your girlfriend. Process status message, the same thing, and probably this also the same thing. Broadcast. Broadcast. What's going on with broadcast? As broadcast. It's this. What's broadcast? GD. No definition found. Oh. What? Server broadcast. Broadcast. I'm a little bit confused. Broadcast block. I cannot find broadcast, to be honest. It's undefined, of course, because we don't have it. Did we comment that out? Yes, we did. So what we're going to do is we're going to keep this, but we're going to do this, right? So it's only going to return null just to satisfy the compiler. and you will see what I'm doing. Init transports, this function can be completely out in the dumpster. All right, so let me make, wait. So we're gonna make a server. Wait, let's call it node. Let's call it a local node. It's going to be make, and we have a function somewhere here, make server, a little helper function. So we're gonna delete this and paste it actually here. Then we're gonna comment that out like this. And then we're gonna say, we don't need a transport. We want a crypto private key. Of course, we're gonna delete this, and this is not this crypto, but this crypto. All right, and then we can say something like make server. Make server. We need to give it an idea, and we're gonna say it's the local node. Local node like this, and then we say the crypto private key. That's gonna be pk priv key. Is going to be crypto generate priv key like this, and then we can insert this by reference like this, and then no. Here, priv key like that. And then we can say local node start like this. We're gonna quickly comment this out real quick. We're gonna make run to see if everything is fine, and it isn't. Server 115. These things, we're gonna comment this out. And we're gonna quickly do this again. Segmentation fault. Why is that? That's a good question. Segmentation fault. Nil pointer dereference. Add block without validation. Blockchain 83. You don't need line numbers. You don't need line numbers. Line numbers will distract you from your focus. The point, sometime in your coding career, you will turn off line numbers, and that is the moment you turn into a pro. Because line numbers, you can basically do like 2, and I'm in line number 2, and then if I want line number 100, boom. There is no line number 100, like line number 30, boom. It's line number 30, right? Blockchain 83, right? So that's here, exactly here. BC logger. That makes no sense to me. Invalid server start. Where is the start function? Here. RPC decode. It's basically in a setup server, new server like this. Okay, this is actually did we forgot something? Some little debugging. BC logger, is it that? Is the logger just completely out of the game? That could be, right? BC logger. What is this thing? GD. The logger is L. Okay. So if you go to server, new core blockchain ops logger, but there is no logger. Oh yeah, of course. So what I'm also gonna do is I'm gonna add some giveaways in the chat with Nightbot. I still need to configure this guy a little bit more. If you guys can spot any errors before me, you will get points channel points. And the guy with the most points, of course, gets something very good, right? Like this. You guys could spot this, that basically we say if the logger is nil, we basically create a new logger. Why? Then we won't have this error, right? Make a run and it will all be good. All right. So we start our validator because if we give it a private key, it will automatically turn into a validator. And what is a validator? In a network of nodes, in a network of blockchain nodes, there will be validators. And basically, we have one validator, which basically means that that guy is the boss and he can forge a block and sign a block with his private key and broadcast a block. So he is in charge of blocks. So he's basically creating new blocks, right? No transactions because we are not sending any. So that's all fine. And in our previous implementation, we broadcast the blocks and every node just process it and add it to his blockchain. But because we are decoupled completely the transport, because we're going to implement the TCP transport, it's just him alone in the network. So now we're going to attach our TCP to this node. And we're going to do that by putting, let's say, TCP transport inside of this opts. We're going to give it a pointer. Actually, that should be an interface. I know. That should be an interface. Just like we had before, our transport was an interface, but for now it's okay. Because actually, to be honest, let us be honest, nobody's going to use WebSockets, right? We're going to use TCP for gossip thingy, for our gossip network. There's no need to use UDP. There's no need to use WebSockets or whatever protocol, just TCP. TCP is the language of love in the tag world. Everybody knows the language. For a short period of time. So we have this transport here, right? So if we make a new server and we call start on it, if we call start, we boot up the transport. Actually, why don't we do it already? We're going to do it in start here. So we're going to say as transport, TCP transport start. Like this, okay? The next thing we need to do is in this make server, we need to make sure that we say TCP transport is going to be a network, new TCP transport, and we need to give it a port. Damn, the CS code is going to be, like usual, 3000, the classic port. So if everything goes well, and we make run this, TCP listening to port, so TCP server is boot up, and we're going to make this a little bit better. TCP transport, we're going to say TCP listening to port, TCP transport listening to port. Yeah. Main. Server this side. Okay, so now we're gonna do this TCP tester, right? So this TCP tester is going to do his shenanigans. Wait, this makes server. That doesn't make any sense. With local node start. Do we block here? We probably block here, right? Oh yeah, we block. So we say go, and we don't block. We're gonna time sleep for 1 second. The reason why is because otherwise it could be that we are sending messages to our server that's not even boot up already. We need to wait. A scuffed version of the await of the async await. This we don't need. This is already done. Done. Oh, this is asleep here. And then we get, yeah. And then we're gonna say, we're gonna loop. Boom, boom. Clear, make, run. All right, it's working. It's working. So our TCP tester, 10 Go routines, sending us hello you, connecting to our server, blah, blah, blah. So the next thing we're gonna do is do our peer shenanigans. We're gonna do our peer shenanigans. Let me quickly check. Man, what's going on? Something is wrong with the chat. I don't know. It's YouTube. I think, I don't know what it is with YouTube chat. They should, I don't know why, but they have so much money. Why don't they make it a better streaming platform? I don't understand. But yeah, it is what it is. So what we're gonna do is, if we open up our transport on the other side, TCP. So we have a read loop. I'm gonna open it this side because I think it's better for viewers. TCP transport. This side, right? And I'm gonna open up server this side, okay? Accept loop. So what is the accept loop? The accept loop is basically, there's the read loop I wanna explain. So for each connection that's connecting to our server, we spin up a read loop where we read from the connection. But we're gonna do something very fancy. This is gonna be high-level Golang tactics. Trust me, what are we gonna do? This is basically a small chance you find this on the internet. So what we're gonna do is, we're gonna make a peer map. And that's gonna be a map of, let's call it net addresses. And we point to TCP peers, right? That's what we're gonna do. Let's create this map here, peer map, peer map. I will put it up a little bit above. That's better for. It's going to be make a map of net adder mapped to pointers of TCP peer. Actually, I don't like to make maps. I'm going to do it like. No, I'm going to do it. I'm just gonna make it. I'm sorry. Okay, that's fine. The next thing we need to have is a way to communicate between our transport and our server, because our transport, TCP rather, is basically making the peers, right? Here, you see? So it's making a peer. And then it reads, it spins up a Go routine to read from the connection, right? But what we want to do is basically, we want to keep track of these peers in our server and not in our transport layer, because we need to know it. Because if we received, for example, we're creating a new block and we want to broadcast it, we're going to loop through all the peers and send that message. So we need to have some kind of a sense of feeling how many peers we have. Maybe we want to limit the peers. And I don't want to do this in TCP transport because I think the responsibility of handling the peers is not for the transport, but for our node, right? It's the transport itself, the way of transporting the messages, that's the responsibility of TCP transport. But handling the peers, not. That's a design decision you need to make. And basically both are kind of good implementations. It's just the way you want to prefer things, right? So what we need actually in server is a way to communicate. So we're going to say a peer channel. And now I need to, it's going to be a chan of TCP peer. peer channel is going. Wait, this channel's a long time I did this. It's basically make. Is it like Chen? Make Chen. TCP peer. The question is, do we need a blocking channel or do we need an infinite channel? We want a blocking channel. Why? Because we want to add deterministic. We want to add these peers without any race conditions, I think. We will see. It doesn't matter. We will see what's going on. So we have this peers channel. The next step, we could do something like case peer. We read from the peer channel like this. We could say fmt println, or we could say new peer. Whoa. %v for verbose. Of course, a new line and a peer like this. Okay. But this can have some issues, and I will explain why. Because this sounds straightforward, but there are some caveats in doing this. There are some caveats. There are some nasty little snake in the grasses that can shoot you in the foot. And the reason why I know this is because there are a lot of holes in my foot. Trust me, a lot of holes. Peers channel. Okay, the next thing we need to do, we need to find a way to pass this peers channel to the transport. So we're going to say peers channel. It's going to be a Chen TCP peer, and I think it should work. It could be. This is all at the top of my head. So if we are running into issues, if you find something that's not good, please let me know. Actually, this peers, yeah. TCP peer channel like this. Peer Chen. Okay. All right. And then what we're going to do is each time we have this peer, we're going to say T peers channel, and we're going to dump pipe or whatever you want to call it, this peer into this channel. Yes. So the next thing you need to do, wait, it's confusing, not gonna lie. The next thing we need to do is basically when we say new TCP transport peer channel, yeah, that's gonna be an error. So we go to main. Wait, our server is not even being made. So we're gonna make, this is, a lot of things we can do, actually. A lot of things we can do to make this work. If we go to server, right? Where do we make this channel? At boot up, probably. We make it here. Peers channel. We're not gonna do this. Where is our transport? We could do something like peers channel. Like I said, there are a lot of ways we can actually do this, and they're probably gonna change it later on. So peers channel, like this, and then we could say something like as TCP transport. I don't think I can attach it. Can I? Very bad approach, by the way. I don't like this approach, not at all. I don't like this approach. This is very hacky. Super hacky, not gonna lie. But sometimes we are hackers and then we need to do things. Not quite sure if this is gonna work, by the way. Let's see. So how do we know that it works? We know if we see this message. New peer. Not enough arguments. Main 29, 29. That's main 29 here. Oh yeah. I have a better idea. Sometimes you need to be creative, right? Programming, coding is a creative process. It's like painting. There are no mistakes, only little happy accidents. And if I had a brush, I would beat the devil out of it. But I don't have a brush. So we can't do these things here on this stream, unfortunately. So the thing is, we are going to construct the transport in the server directly. So let me open up main so I can copy paste my own code. Wait, it's basically new server, this, and this, and then we say something like, we make the peer chain here, and then we say transport is going to be tr. This is network, so we can say new TCP transport. TCP transport like this, right? We're gonna give it, and what we could do is put the address in the config. That's a good idea. You could say that the listen address is going to be, there's a string like this, and then we're gonna say new TCP transport. That's gonna be the opts listen address, all right? Then we say that the transport, the TCP transport we embedded here. It's going to be TCP transport like this, right? Oops, listen to this. Why is this? We need a chain. Yes, of course we need it. I know. Hey, yo. And then we need a transport like this. Yes, tr. All right. Look at this. This is much cleaner, isn't it? The next thing we need to do is, instead of, if we make this server here, we give it a listen address, right? And we say it's 3000. Up, make run. You see this? This is what I call next level programming. It's working perfectly fine. So we get these new incoming TCP connections, and then we say new peer. This is actually the important message. This is the new peer, and that's basically from our server loop here. This is this thing. With channels we communicate, and yeah. Are there any questions so far? Are there any questions? The question rather is, are there people in watching? That's the main question we need to ask ourselves. No idea. Luckily, I have the ability to talk to myself, right? Luckily. But it's needed because this video is also recorded, right? This stream is also recorded. So if people watch it later on, and I'm I need to do as if I was giving a performance, you know. All right. What time is it actually? Almost 1 hour, that's good. Can't we, Philip, can't we use an existing TCP library instead of creating our own? Of course we could. But Onias, I'm here. Yeah, I don't know. It's my chat on OBS. It's I don't know what it's doing. It's basically tells me that I'm alone, home alone. Philip, to answer your question, well, that depends. That's something you need to ask yourself, because if you are working in a big giant company, for example, Netflix or some FANG company, and they want you to implement something real quick, you're probably going to use an already existing library, right? Why? Because it's a proven library, probably, a lot of support, a lot of contributors, I don't know. So you're 100% sure that the implementation of that TCP protocol, the implementation of that gossip is working 100%. So that makes sense. But if you are programming something for yourself, you can never, that's some advice I'm going to give to you, right? Never use, if it's for your own project, right? For your own educational purpose, never use something that exists. Always write something yourself, because you're going to learn so much more. It will probably not work the same. It will probably not be the best implementation on the planet, but the amount of value you are going to get from it is incredible. And that will, trust me on this one, that will make the difference between a software engineer, a programmer, or basically a god. That's the difference. Because even though later on you are going to use already existing implementations and there is some issue, there is some problem, you are going to know how to fix it because you did these things already. But a normal programmer that does just npm install, cargo this, go package from here, that guy has no clue. He's actually a fake programmer because the only thing he can do is use packages and follows tutorials. That's my thing. But if I would do this actually for another company, for a client or something, for a customer, I would probably use existing solutions. Why not? Especially in crypto. It's very sensitive information, very crucial technology. So yes, makes sense. Thanks. No worries, Flip. No worries. Okay, but now we need to make some kind of a nice API around this whole thing, because I'm thinking. And it may sound that the stream is freezing, but I'm thinking. If you think the stream is freezing, I'm thinking. That's the rule of thumb. Okay, so let's say okay. Panic here. What the hell? Some leftovers, leftover relics from ancient times. So what I want to do is basically find a way if decoding the message works. Because we already have this decoding, right? We already were sending messages, but through a local transport, not a TCP. And our local transport, the implementation was good, like I mentioned before, until it lasted, and that was yesterday. Because we're going to sync blocks, and I need to send a lot of messages over the wire. And I didn't like it. Okay, so something that we forgot actually, if you open up TCP transport actually here. The read loop. So basically this is the message, right? Right here. The question is, how are we going to communicate this thing? We could do things, two things come to my mind. We could, instead of doing this read loop in the TCP transport, we could move the read loop to peer. We could say something like peer, TCP peer, read loop, like this. Man, it's itch, my nose itches. Read loop like this, and then we could say the same thing actually. Let's copy paste it. Read loop. Yeah. Something like this, right? And then just read from the connection. What is this? Continue. Like this. Handle the message. But then we need to have a server, a channel from our server that reads a message, an RPC channel, which we already have, but it will not be compatible. If you open up server, we can see this. You see we have an RPC channel, this one. That's the one we used in our previous implementation. So if the read loop is in the P, right, what we could do is then, if you open up server, we could do something like each time there is a new peer connected, TCP. Man, this is itching. What the hell's going on? We could do something accept loop, and then we say go TCP, go read loop here. But we don't do this, right? We could say into our server, each time we get this. To be honest, what we could do is this. Man, my IDs are insane. Look at this. We could give a channel inside of this message channel, RPC channel. RPC channel, why not? And it's a channel byte maybe, just for now. Wait, this is not the correct spot. Yes, here. No. Here. We could say RPC chan, like this. It's going to be a chan byte, right? And then we say RPC chan, and we pump in this message like this. Actually, boom, right? So then we say here, for each peer we have, we say go peer read loop, and then we give in our RPC channel. Actually, we're going to call this message. I'm going to keep this here just for backwards compatibility, because I think if I'm removing this, you're going to have a bad time. So we're going to say message chan, like this, message chan, boom, back to here. We make a new one, like this, but we say message chan, hop, and we're going to call it a channel of byte. Wait, message chan byte. Jackie Chan. Man. All right. Something like this. And what's going on? Nothing. Cool. And we're gonna clean up this thing because there are a lot of things we can basically cut out. But like I said, for you know how it is. Like you delete something, and then everywhere in your code there is errors because you deleted something. And if we need to debug this, all 2 streams you were debugging and fixing things, this stream is gonna be a writing stream. Go peer read loop, and then we're gonna say as message chain, right? That's what we're gonna do. And we can say this. It doesn't even matter. It doesn't even matter. So each time we get a peer, we boot up the read loop from the peer, give it a message channel so we can communicate. And then we have this logic, right? This is the RPC logic, which we used for our... And to be honest, I think if we are smart and we reuse this RPC channel, I think it's gonna work right off the bat. Could you imagine? That would be insane. I think this RPC channel, I'm gonna quickly check what that is. It's a reader and a net adder. Because if we can make this into an RPC channel, this message chain, then everything is gonna work. Yeah. That's what we're gonna do. That's what we're gonna do. Oh, what am I doing? So, all right, a couple things that are basically a little bit weird. And that's, you know what, we're gonna say RPC channel. It's gonna be channel RPC. Can you guys see this on the others? Yeah, okay. So what's an RPC? An RPC is basically this. We don't need... Let me open up RPC, because I am... RPC. Hello? Yes. From is a net adder. From net adder, and it's going to be p com. Is it the remote adder or the local adder? That's a good question. I don't know. Let's take remote. West network. We don't need this. And I think, does this return a string? Why don't we use our own net adder, by the way? Can I do these nasty things? We can't. Wait, this is actually so simple that it's confusing. I'm not gonna lie. And then we need to specify the reader, but we don't have a reader because this is a byte. So what we're gonna do is we're gonna say the payload is going to be a bytes new reader. let's cheese it up a little bit and say MSG. And why is it still not used? All right, we're getting closer, guys. We're getting closer. But this is a problem. So why is it a problem? Let me open up this. So this is a net adder, and the only thing a net adder is, that's our own type that we made, and it's basically just a string, I think. Can I go to GD this thing? Yes. You see, it's just a string. I don't know why I did this. So actually what we need to do is, I'm gonna make this into a net adder. All right. And now everything is broken, I guess. This is a pointer to a function. Oh, what is this? All right. Now RPC is broken. Decode message. Decode message. From. No boy, it's net adder. We changed the rules. We changed the rules. And you all gonna obey. We changed the rules. Okay, that sounds good. And then server. Peer loop. RPC channel. Is this gonna work? I don't know. Oh shit. Make run, let's go. Okay, transport 52. I think it's just a local transport, right? That's because of the net adder shenanigans we did. But it's no problem, we're gonna fix this. So this adder from a local transport is gonna be net adder. And then the same thing here. No. Used to already Golang standard library things. That's always a good thing. In Golang, the standard library is so huge and so good. It's one of the best standard libraries I ever seen in my whole life. Minimalistic, but very composable. And that's what it's all about in code. It's the composability of your things. That's why you should never do object-oriented programming. Stop it. Don't do it. Never. Net adder. Oh man, what's going on? Does not implement. Yeah. Let's go. Transports local again. I'm gonna comment everything out if this keeps going. This address, man, it's killing me. Make run. Okay, a couple things. Local 34 and 74. 47. Local transport. 47. Pierce 2. Why is that? What's 2? Aha. Got him. Net adder. One more thing to go in server. And you can test this. 1, 4, 2, boom. Process gets block message MSG from. You know what? You don't play anymore. Make run. All right. Panic. That's what we want to see. Or panic. Why? Because unexpected end of file. First thing we're gonna do is take a little step back in main, because we are spinning up 10 of these guys. We're gonna make one. Okay, so we still have this thing. Okay, it's no worries. So fail to decode. unexpected end of file. Let's go to process message server. Let's go to TCP transport on the other side, by the way. Unable to read file. Where do we fail to decode message? Failed to TCP main. Where is this error message coming from? Ah, I know where it comes from. It's from, yeah, of course, I know what's going on. So yeah, so what we did is basically we hooked up our thingy with the RPC channel, right? But the RPC channel actually, if you go to server, I will show you. Of course, why didn't I? If you go to server, so basically what it does is it actually tries to decode. It tries to decode what we're sending. But we are sending in main, just to test things. If I open up main, we are sending hello you. Our blockchain doesn't have no fucking clue what hello you is. So that's why this nasty error is there. And I agree, we should make that error better because a panic in this case is bad. It's not good. So if you go to RPC, fail to decode message, right? So it's this one, you see? Fail to decode message. So why are we panicking? Because I probably think we... Can I go to any kind of implementation? RPC decode thing. RPC decode thing. I see what's going on. So this is actually bad, right? So what I do here is I'm saying a message error is this RPC decode func, and if it is an error, I log it, but then we go to the next line. So, but the next line is expecting a message, right? But if we have an error here, the message is nil. So, continue, right? Ali, come on. What's going on? Ali, come on. Make run. So now it's going to be the same thing, but now the error should be a little bit better, right? Error failed to decode. You see, there is no panic. Our system keeps running. Because yeah, it's just we cannot be or the whole chain cannot be the victim of some one guy sending a hello you message to our blockchain and the whole chain crashes. We are not Solana, you know. No, Solana is a good blockchain. It's a good blockchain. Wait, let me quickly check the stream health. All right, and don't forget, if you like this kind of streamings, if you like blockchain development, DeFi, quantitative trading, we are even making our own cryptocurrency exchange in Golang. If you like this, please subscribe to the channel, ring the notifications bell, give me a thumbs up. My goal is to provide you with real knowledge, with real in-depth knowledge, how these things work. And not like a, how you see it, like a high-level tutorial about connecting a wallet. I mean, who cares? It's all over the internet. I want to give you very in-depth information, how these things work under the hood, so you have a clear understanding. It will make you a better engineer in general, I think. Okay, so how are we going to test this? So what we're going to do is we're going to, this TCP tester, and of course we're going to boot up multiple servers and let them communicate just like we had, create blocks and distribute the blocks, broadcast the blocks and all these things. That already worked a couple things before. But now we're going to just test if the handling of the messages is working fine. Satoshi, how about Reputing blockchain in Bitcoin not on chain. Re-putting blockchain in Bitcoin not on chain. What do you mean by that, Satoshi? How about elaborate a little bit more. I'm happy to answer your question if I can understand it a little bit better. And this chain is pure for educational purposes, right? This blockchain is, there's a lot of episodes on my channel about this. It's basically just to show everybody the core fundamental building blocks on how a blockchain works. Transport layer, virtual machine, transactions, blocks, consensus, decoding, validation. All these building blocks, that's what we are doing, that's what we are building to give you a better understanding of how these things work. I don't know what your question is, Satoshi, but if I can try to make an assumption about your question, is like Bitcoin, for me, Bitcoin is actually the holy grail of blockchains. But the problem is that Bitcoin is not designed to be designed for being a distributed virtual machine, right? That runs code. That's the problem, and that's what Ethereum is. So instead of that's something I actually think that's wrong in the community is everybody's building his own chain. Okay, I'm building an own chain, but it's just for demonstration, right? But everybody is building his own protocol, and every protocol does just one thing a little bit better, right? Maybe a better programming language to write smart contracts, maybe a virtual machine that's a little bit faster, or whatever, or a bigger block size. But I think the community should focus more on making Bitcoin and Ethereum better instead of making all these protocols, right? Because no, it's being changed on chain. I have no clue what you mean. Okay, I have no clue. All right, so TCP tester. We're gonna write a real message to our blockchain. So let's do RPC. What do we have? Okay, let's make something like, let's make a transaction. Let's make a transaction. That's what we're gonna do. Main, open up this thing, because I think I have some code that does it. Send transaction. This case, yes. So we're gonna copy this whole shebang, right? Boom, boom. We're gonna paste it here. Boom. Do this. We cannot return, so we panic. And then we're gonna say, instead of this byte hello world, we're gonna say message bytes. All right, and is this working? I have no clue. Let's go. It's working. You see, because, and this is the virtual machine. And look at this. So it's working. We have one transaction, and I want to show you guys that it's working. Maybe a little bit in depth. You say. How can I show this server? Satoshi, you do know I am Satoshi Nakamoto, and I'm the one that takes the final decisions from now on. You will see, okay, man, it's good. From now on, you take the final decisions. If you are Satoshi Nakamoto, you can take the final decisions, my man. It's all good. You tell me what to do, and I will obey. I will obey to you, my friend. It's pretty funny. All right. Don't forget to subscribe, Satoshi. Don't forget. or I will dox you because I know who you are, but I will keep it secret for myself, okay? Our little secret. Sending a transaction, yeah. That's working. Let me open up blockchain because blockchain. VM. Executing code. What kind of transaction are we sending, by the way? We're sending our own bytecode. Isn't that amazing? So we have a little virtual machine, just a very small one. It can add, subtract, multiply, divide numbers, and it can also store into the state. We also have a little state where it can store results of a function or whatever into our blockchain. Actually, if I think about it, it's pretty crazy what we already built, not gonna lie. What I want to do is just to show you that it's working, is basically say that the result, what's going on, VS Code, VM, result is going to be VM, stack, pop. I have no clue what's on the stack, to be honest, so I cannot cast it, but it doesn't matter. You're going to say fmt, printf, verbose, like usual. My hands are getting cold. VM result, and a new line. Boom. Nil. Oh yeah, but we stored something into the state. Is it possible that we did that? So it's executing. Actually, we don't. Oh, we do. We do. Executing code, right? You see, executing code. So this transaction is actually working through TCP, which is nice. I'm just curious what we're doing in this thing. I think it's the state. Contract state, by the way. PC. Where is our state? Roy, hi, hello. What's poppin'? How is your day? What is going on? What is going on? Make run. I'm curious what's in the state. I think the contract do something in the state. Yes, we're storing 5 in the key foo. That's what we're doing. Is this live? Yes, my friend. Is this live? You type 1 and I will tell it's 2. So you're sure that we are live and that I'm not a recording. All good. Okay, so that's this transaction thing. That's working fine. So we are doing a good job. Okay. Server. So I'm thinking. So what I want to know, can I boot up 2 nodes now? That's the question. Do they work? Do they work? What I'm going to do is, instead of these things, this MSG channel can be gone because we fixed that. We're going to say C nodes, which is a slice of string, right? Of maybe net adders. Doesn't matter. Strings is good. So what we're gonna do, if we don't have if validator yo is good, we start the transport. That's good. Then we're gonna say, maybe we do something like server bootstrap network or something. Yeah. Man, this VS Code Vim is too slow for me. So Bootstrap network, we're gonna say for adder or node adder maybe in range as Bootstrap nodes, seed nodes by the way. We're gonna do something like net dial TCP adder if error if the error is not null. What I'm doing, this is not correct. This is correct. What are we gonna say? Good question. We're gonna print f could not connect to con. Let's call this verbose. And a new line like this. And then maybe continue or something. And now we have this connection. And now I'm thinking, what do we need to do with the incoming connection? So we have outgoing connections and we have outgoing peers and incoming peers. That's important. And what we could do is actually, if you go to TCP transport, is actually put that into the peer. You could say incoming. How do you write incoming? Good question. Incoming. Know what we're gonna do? Outgoing. That's the trick. Outgoing, that's gonna be a bool. So we're gonna say if it's outgoing, it's true. If it's incoming, then outgoing is false. That makes sense. Why do we need that? I have no clue. We probably will need it in some cases. I'm thinking. Bootstrap network, that was what we're doing. For now. And why is this actually? That's better. And what we could do is basically just this, right? We could say as peers channel, because we need that peer, do we? Of course, we need that peer. We need that peer. Yes, 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 we need it. The same thing with this transport, right? So if we open up transport the other side, TCP transport. So we're making this peer somewhere. Where is peer? Here is peer. Right? So we could actually do this. Oh, this, and we say this and this. Yeah, that's the only thing we need to do because it goes to our channel. And that basically makes sure that the peer is going to read loop and all that good stuff. Yes, yes. Man, I should go to the bottom real quick, to be honest. Let me see how many. Let's keep grinding. I don't care because the time that I'm going to the toilet and I come back, everybody's away from the stream. So I need to take the pain like it is, like a real man. That's what I'm going to do. Take it like a man, especially for you guys. So you have zero down time. Isn't that amazing? Isn't that amazing? What a guy. Yeah, that should work. So we arrange through all the shenanigans, then we dial our node, and yeah, let me see, is that working? Main. So what we're gonna do is we're gonna make another node. I'm gonna make server. Actually, let's call it remote node. Remote. Shit, we need another. No, we don't need a private key. I don't care. We are the validator. The remote is no validator, so we're gonna say nil. And of course, the make server is going to do this, right? So I'm gonna put the address in here. So we can have different addresses, right? Like this, right? And then we say the local node is going to listen to 3000, and the remote node is going to listen to 4000, okay? No private key, yeah. And then we're going to say go remote node, go remote node start, okay? And we're going to block. Let me see what's going on. I have no clue. Probably not going to work. It's working. But you see this TCP transport listening to port line? I actually want to print out the IDs so we know who is who, right? TCP transport listening to, should be in TCP transport. We can't because we have no access to the ID here, right? We don't care because we go to server, right? We go to server. Where do we boot this thing up? New server, TCP transport. Where are you? Ah, here. Where do we start this thing? Here. Cool. Boom. We're gonna say fmt printf. And normally you should use the logger. I know. Do we have a logger, by the way? S. Look at this. Log TCP. Accepting TCP connections on. And I know this is not the best logger. Well, it's a good logger, but it's not the most user-friendly one. So we need to do something like this, MSG, and then we say that the header you're listening to is going to be as listen header, yeah. And we're also gonna say who we are. How do we do this? ID or something? S ID. Clear. I cannot even make it run. All right. You see, it's working fine. So we see accepting on 4000, that's the remote, and 3000, that's we. So now we have an understanding who the boys are. Who are the boys on the network? Nice. Very good. All right. What was our planning actually? Ah, yeah, 2 nodes. Yeah. So how can we make this? Well, actually, what the hell's going on? Bad shortcut. I hope you didn't see any nude pictures, because I would ruin your day. I'm not gonna lie. So What I was thinking is it should actually work, I think. So let me run this and see what's going on, because... Oh no, our broadcast method is fucked up. That's true. That's why it's not working. So we need to do some patching. So we can do this. It's all good. All good. These two I'm gonna save them for later on. Process gets block message. MSG from decoded message. And that's a net adder. Okay. But that's no problem, but we're gonna say that this is coming from a net adder, like this. Broadcast. Yeah, so for broadcasting that needs to be addressed, because broadcasting is going to be actually kind of the same as this, but it will be, instead of ranging through the transports, we cannot broadcast. We need to broadcast ourselves. Which basically means this function can be deleted. So we're going to say for peer in range as peer map, and we need to lock it. We need to lock it here, because accessing our peer map, adding to peers, it's basically a concurrent data race problem, condition, whatever you want to call it. So we need to have a sync mutex soon. So we're going to range through this, and that's basically the net adder is going to be this, right? And this is going to be the peer struct, right? And then we should do something like, what we could do is return, no, not return because we're looping. If r equals peer send payload r is not null, like this. We're gonna print it out. Print f peer send error. Peer com remote. I think it's the remote. It could be the local, but I don't think so. And of course, peer.send does not work, I know, but we're going to implement that soon. So peer send error address. I also want to print out the error, right? Something like this, I don't know. R. What is this? It's not being used probably. Yeah. Actually, like this. So broadcast is very simple, right? So we basically have a payload, we range through all our peers that we have, incoming and outgoing, and we're going to call a function send. And send is basically going to peer. No, wait, it's TCP transport like this. So we're going to make a function, func peer, TCP peer, send, help, byte, error. I'm going to say return peer con read. Is it right? Right, byte. Come on. B. No? Or is it read? I think it's right, to be honest. Or not. So basically we have a connection and we write to the connection, right? We write to the connection. We actually don't care. We actually don't care about the number of bytes we've written, right? I mean, We just do this, right? Yes, I think that should work. Let's test this. Make run. So there's any new blocks, but the thing is, I don't think it's working. Somebody is telling us MSG new block, but I want to explicitly know who's making these blocks, who is getting these blocks. How can I new block? RPC maybe? Not. Where is it then? Blockchain? Ah, here is it. Ah, I know what's going on. It's in server. We basically commented this out. Here, it's this one. It's the prefix. Opt transport header. That's not gonna work. It's gonna be TCP. TCP transport. What do we have here? Actually, do we have? We don't even have a server. We do opt ID maybe. Yeah, now it's working, right? So the local node is basically creating these blocks, right? And it should broadcast them to our peers. But it's not doing that. It's the Bootstrap network. We didn't add this. That's nasty, I'm not gonna lie. So actually it wasn't working the whole time, hey? Making so many mistakes. So what we need to do is make server, right? So I want to have we need to have the seed nodes. So I'm going to say string. That's going to be an issue. Let's say 4,000, right? Can I do this? Can I not do this? Wait. Seed nodes, which is a slice of string. So seed nodes like this, right? And we're going to say the same thing here. We're going to make a slice of strings. And we're going to say this is going to be 3,000. Is this gonna work? I have no clue. Yes, it's working. Okay, but we still don't broadcast things. Oh, could not connect to null. Where is this? Could not connect to null. Ah, it's this one. And that's probably because I have no clue why. We will see. Println header. Make run. Bootstrap networks. So we start the transport. I need to check because it could be that we are. Yeah, this read loop we don't use anymore. New TCP transport, that's already been done. Then we call start on our transport, and I need to check where is it, and why is this important function completely at the bottom. So we listen, yeah, and then listen, and then we go accept loop. So I think it's not blocking, but the accept loop is important. So not quite sure if this is gonna help, but it's a little hack for now, okay? Whoa. What's going on? And you see the focus is drifting away because I need more carbs, I'm hungry. Trying to connect. Why don't we see it in our peers anymore? Who knows? It's like Bootstrap is basically blocking for some reason. Right? Because if I panic here, would it work? Nope. How is it possible? Bootstrap network. So what we do is we turn this thing. Adder. What is adder? It's basically a string. Make run. So that's a little bit better. I think it was blocking on a channel. We need to inspect this in depth soon. But so we have a new peer. Yes, that's true. We have a new incoming connection. So that's working out pretty fine. So the only thing that we need to test if this broadcast is working, that's the question. We don't care about this broadcast. Not peer. Println. Come on, broadcasting. Okay, that's good. It's good that we don't see. Yeah, we see it because it's one. We broadcast, but nothing happens, right? You see, the local node creates a block, and then he says he's broadcasting, but we don't receive it on the other side. But we also if there's an error, we print this, and what do we then? Maybe we should. What I want to do? Let me see what the peer map is, right? What's in the peer map? But maybe. Oh, of course, we made a big mistake, and nobody's telling me this. Of course, we have a peer map, but it would be nice if we actually assign some peers to that peer map. That would be nice, to be honest. God damn it. I'm so hungry. My stomach is growling like a bear. Let me quickly check some things. We'll quickly... Holy crap, that's insane. All right, so what we need to do in this peer loop. And my camera didn't turn off, and that's good. Yesterday was overheated, by the way, and a couple times he went to sleep, but I changed some settings where the temperature can be super high now before he shuts down. Just as a side note. So where is this peer? Here is this peer. Look at this. What are we gonna do? We need a mutex. We need to remember this for the next time. So we're gonna say to do add mutex, please, like this, and then we say server peer map peer con remote address, yeah, is going to be the peer, right? Like this. Okay. Yes. Wait, it works, but the logging is again printf new line. Yeah, where am I printing f? Printing f, printf. Printf. Here, new line, yes. No new line. New line. Wait, let me open up. Make run. Big screen TV. Yeah, it's still not new line, but it is what it is. So what happens is, what is this broadcasting? Let me quickly fix this first, because what the hell? Here, this thing. Let's go to the big screen TV. Clear, make run. All right, so we get new peers, we boot up, we bootstrap the network. Local node, height 1, a remote node, height 1, that's good. Now he's producing a block again. He's forging a block every 5 seconds. Why are we stopping? Oh, that's basically just my terminal is garbage. So you see height 2, remote node, height 2. It's all working fine. So let's, the last thing we do before I'm going to end the stream and going to eat, I'm probably going to stream back tonight, not quite sure, is we're going to add a third guy to the party. That's what we're going to do and see if we can have 3 nodes on our network main. We're going to do this real quick, like we never did. We're going to do it so quick like we never did before. So what we're going to do, we have a local node, a remote node. We're going to say, copy this guy. We're going to paste it in. We're going to change this to server. Hop. Remote node, we're going to say remote node 3 B. This is going to be remote node B. This guy is 5000. And we're going to connect the local node with the remote node. And the 5000 guy. Right? And this guy we're going to connect with, I don't know, 3, with the yeah, this guy, whatever, it doesn't matter. The most important thing is that we that our local node is connected with everyone, because that's a validator. And of course, actually it broadcasts. So to be honest, everybody is broadcasting, right? So what we could do is, so we connect the, look what we're gonna do to see if it works. We're gonna only connect the local node with the remote node, right? And then we're going to connect the remote node. Man, this is so confusing. What the hell is going on? And then we're going to connect this guy with the 5000 guy, right? And this guy connects with nobody. Okay? So he will... So in this case, if the broadcasting mechanic works, Local is going to send it to remote, and remote is going to broadcast it to remote node B. That's what's going to happen. So normally everybody should be at the same height. And if it not works, then we have an issue. But it should. Remote B. That should be actually it. Make run. Please. Should we do big screen TV? I don't know. Let's do this. It's fine. It's fine. It's fine. Yes. Look at them. Look at this. Remote, local, B. They are all at the same height. We did it. We are amazing. We can finally go eat. Our TCP transport is done. So we actually can sync our blocks. Finally. Man, holy crap. That's amazing. In only 2 hours. That's fine, right? That's not too bad. That's not too shabby. That's not too shabby. I'm not gonna lie. And if somebody has questions, please feel free to ask. I'm here at your service. Don't forget to, if you want to learn more about blockchain development in general, or Golang, or DeFi, smart contract, Solidity, even quantitative trading, consider subscribing to the channel, or join the Discord in the link below. You have a nice community out there where I notify everybody what I'm doing. People can give some feedback, ask some questions about the projects, because everything is on GitHub. So if you want to play around with it, you can. And if you have questions, hop into the Discord, DM me, or DM someone, or just whatever. It's okay. Yes, we are syncing. Well, we are not syncing. We are doing the same thing we did before, but over TCP instead of our local garbage shenanigans. It's beautiful. It's beautiful. So if there are no questions, I'm going to wrap it up and try to not starve from that, from the hunger. And I probably going to see you guys maybe tonight. Not quite sure. Maybe, probably. We're going to do some cool stuff again. And in the next week, I'm planning some cool stuff. We're going to keep working on the crypto exchange from scratch. We're going to do some Solidity protocols. I'm going to do a lot of good stuff, real in-depth stuff with super value that's not being found on the internet and not being taught on YouTube, only here, only at my channel. Thanks for watching, and I'll see you in the next video or live stream. Bye-bye. Thanks, guys. Much appreciated.